Okay, another thing we need to know about waves is that they travel from A to B. Okay, I can think about the movement of waves. That means that we can think about wave speed. Okay. Now, if I'm sitting on a harbour wall or something like that, looking at the ocean waves, I could think about waves travelling from A to B. If I know that distance, then I can get my stopwatch out and I could measure how long that takes. Maybe seconds, for example. Obviously, I can just think about the wave speed as v equals distance divided by time. If I want to have letters, I could use s over t, because we use s for distance and we use t for time. All right, in terms of units, that would be meters per second. Okay, so that's straightforward, isn't it? We can look at a wave, we can time it, we can measure the distance. It's a bit difficult if you're in the ocean. It's hard to get your meter rule out and measure distance, isn't it? And measuring time, well, that's fine as long as you've got a good reference point. But I guess it's problematic to think about measuring wave speed like this. Okay, but there are other ways we can do it. For a start, a lot of waves are really, really small and they travel quite quickly. So if you're there with a stopwatch trying to measure one wave going past from one point to another, there's going to be a lot of human error involved in there in terms of reaction time and that sort of thing. One way you can improve your precision is, instead of measuring the time it takes for one wave to pass a point or between 2 points, maybe you could measure how long it takes for 10 waves to pass in a certain amount of time. Okay, or even better, 100 waves. Right, but then of course you're going to get your answer, and you're going to have to divide that. You're going to remember to divide it by 10, or divide it by 100, or whatever it was you were recording. Okay, so you can improve precision. You can improve an investigation by trying to time how long it takes 10 waves to pass a point, rather than just one at a time. Okay, just want to put that out there. So yes, we can think about wave speed in terms of distance over time, but let's think about how we referred to how far along a wave we were. We talked about wavelengths. That was our dimension along a wave. Okay, it's still in meters, remember. Okay, now we could measure how many wavelengths pass a point in a certain amount of time, and that would give us speed. If I expand this equation, okay, I could say wavelength, which is lambda, multiplied by, if I take out this, I would have to write it like 1 over time. And remember, we had an element of time we're discussing in the wave features video prior to this one. Okay, 1 over period. Okay, that kind of gives me the same thing, and you can see it's very similar. That's in meters, that's in seconds. Okay, looking very similar to this one, really. Okay, if I expand it, I get that. And if I remember that 1 over t is the same thing as f, I get wave speed v equals lambda times frequency. Okay, because frequency is that. We tend to write it the other way around though, so we've got v equals f lambda, and that's the equation that you need to know for wave speed. Okay, don't worry about all of this. Okay, some of you will be following that, and some of you will be like, what are you talking about? Okay, just know that wave speed is v equals f times lambda. Okay, it's still meters per second, even though we've got hertz and meters. It's speed, it's just the same as this. Okay, we're just using different things to define it. All right, V is for wave speed, F is for frequency, lambda is the length of one wave. All right, do practice rearranging that. Okay, quite often you'll be given wave speed, you'll be given wavelength, and you'll have to calculate frequency. Okay, so if you want to get F on its own, it's being multiplied by lambda, so we need to divide it by lambda to get rid of it. Okay, cancel, cancel. But if I do something on the right hand side of an equation, I have to do the same thing on the left hand side. Okay, so if I want frequency to be the subject, I end up with wave speed divided by wavelength. Similarly, okay, if I want lambda on its own, I need to get rid of F. All right, so I need to divide F away from it, okay, because divide is the opposite function to multiply. All right, because then I can cancel those out. But if I do that on the right hand side, I have to do the same on the left hand side. So lambda is V divided by frequency. Okay, make sure you get that the right way around. There are three versions. You could just, if you really want, just remember them. Bish, bash, bosh. Good luck.